Welcome to the last episode on vectors. Today we'll be talking about basically two category problems. First of all, a vector in component form and direction and magnitude, and the second category problems will be the application of vectors. So if a vector is given in the standard form, let's say this is a vector given in the standard form, as you can see in the graph here, and we assume that the endpoint here is just a comma b. So the coordinate of this point, the terminal point, is ab, and we denote this vector as v. So for a given vector in the standard position, its direction is an angle theta in the positive clockwise direction, and this theta lies between 0 to 2 pi radian, or we can also write this theta in between 0 degree to 360 degrees. So the direction is measured in the counterclockwise direction. So let's say we have a vector v, which is represented by the points O and P, and the direction of the vector is from point O to the point P. That is, O, the center, is the original point, and P is the terminal point. Let us define the vector v equals to, the component of the vector v is a, b. That means if I draw a perpendicular on the x-axis, the distance in the x direction is a, and the distance in the y direction is b. So the angle here will be between these ranges. If we consider a right angle triangle, let's say this point is M. So in triangle OPM, we can apply Pythagorean theorem. In this case, OP squared equals to OM squared plus PM squared. So let's say OP equals to simply R squared, and then this equals to A squared plus B squared. So R equals to positive square root A squared plus B squared. Note here we are not considering plus minus sign here, only positive sign, because it's the distance from the origin to the point P, so it's always positive. So this R is the magnitude of the vector v, so we denote magnitude of vector v equals to R. Now in this triangle, since we have an angle theta, positive angle theta, if I want to define sin theta, then sin theta equals to b over the magnitude of the vector v, or we can also write R if we want. So from this I can get the value of b equals to v, the magnitude of the vector v, times sin theta. Similarly, if I define cosine theta, then cosine theta equals to a over r, or a over the magnitude of the vector v, which can be written as a equals to vector v, the magnitude of the vector v, times cosine theta. As we have seen in our previous video, if a vector has the component form a comma b, this can be also written as ai plus bj. And we have found the value of a and b in terms of the magnitude and the direction of the vector. So we can also write the vector v equals to the magnitude of the vector times cosine theta I for the x-axis direction, plus the magnitude of the vector v times sin theta j. This is a new representation of the vector. We can see that we have a common term in both of these two terms, so we can factor that out. So v can be also written as magnitude of vector v times cosine theta I plus sin theta j. Let's use this representation of vectors in real examples. Example 13 in the lecture note. Write the vector v in the form ai plus bj, where v has magnitude 10 and direction angle theta equals to 3 pi over 4. In this problem, we are given the magnitude and we are given the direction angle, and we have to find the vector. So first of all, we need to find the component a, and we have seen here that a equals to the magnitude of the vector times cosine of theta, and we are given the magnitude and the theta. So a equals to the magnitude of the vector v times cosine theta, and then we can just substitute the values. 10 cosine 3 pi over 4, and the value of cosine 3 pi over 4 is negative square root 2 over 2. So a should be equal to negative 5 square root 2. B equals to the magnitude of vector v times sine of theta, 10 sine 3 pi over 4, which is positive root 2 over 2, and we get positive 5 root 2. For your reference, if you forgot how to find the value of cosine 3 pi over 4 and sine 3 pi over 4, we take help from the unit circle idea. Pi over 4 is here, 45 degree. The value here is square root 2 over square root 2, and 3 pi over 4 means we're in the second quadrant. 1 unit of pi over 4, 2 unit of pi over 4, 3 unit of pi over 4. Using the symmetric property, here it should be negative square root over 2 comma positive square root of 2. As you know, the first component of the ordered pair represents the value of cosine, and the second component of the ordered pair represents the value of sine. We got the component a and b, so we can write the answer in this form: a I plus bj. V equals to negative 5 square root 2 times I plus 5 root 2 j, and that's the end of the problem. Next problem, example 14 from the lecture note. Find the magnitude and direction angle. Of course, the angle should be in the range 0 degree to 360 degrees for the vector s equals to 7i minus 3j and round to 1 decimal place. So first of all, we have to find the magnitude, and we have seen the formula here. The magnitude is defined as square root of a squared plus b squared. So the magnitude of the given vector, note here, a equals to 7, b equals to negative 3. So the magnitude equals to square root of a squared plus b squared. So a is 7 squared plus minus 3 squared equals to square root of 58. If you simplify, you should get square root of 58. And then we have to find the direction angle. Tan theta equals to sine theta over cosine theta. We can write b over a. cancelling the common denominator. So tan theta equals to b over a, and in this case negative 3 over 7, and theta equals to tan inverse negative 3 over 7, and if you use your calculator you should get theta should be approximately equal to negative 23.2 degrees, but we are interested in positive angle. So in our problem the angle is given, the angle should be in between 0 to 360 degree. So in this case, finally when we finalize our answer, we should write theta equals to approximately 336.8 degrees. How did I get this? I subtracted this value from 360 degrees. I mean, I added, since it's negative sign, so I added this 23.2 degrees. I got 336.8 degrees. So finally the vector magnitude, which is square root of 58, and the direction is 336.8 degree. So the vector should be somewhere in the fourth quadrant. And if you note here, s equals to 7i minus 3j, so it should go 7 unit to the x direction and 3 unit to the negative y direction. So the vector is here. So we are looking for this bigger angle, and this is 336.8 degrees. And the r, this is square root of 58. Application of vectors. Example, let's say we have a baseball, and the baseball is thrown with a speed of 65 meters per hour at an angle of 12 degrees from the horizontal line. Write the velocity vector v at the time of release in terms of I and j. Round the components to nearest tenth of a meter per hour. Let's say this is the horizontal line, and we're throwing the baseball from here, and the angle here is 12 degree. The baseball is going this direction, so the angle is 12 degree, and this is the vector, and the initial speed at this point is given as 65 meter per hour. 65. So we have to find vector notation in terms of I and j. So what we are given, the magnitude of the vector, which is 65, and the direction theta equals to 12 degrees, and we have to find v equals to ai plus bj, but we don't know this a, we don't know this b. That's what we have to find. We know the formula. A equals to the magnitude of the vector v times cosine of theta, and b equals to the magnitude of the vector v times sine of theta. Now it's time to just substitute the values. So v is 65, cosine 12 degrees, b equals to 65 sine of 12 degrees. If you use your calculator, you should get this equals to approximately 63.6, and b is approximately equal to 13.5. So finally vector v should be equal to 63.6i plus 13.5j. Next example. A boat travels 10 knots at a bearing of north 25 to west in still water. If it encounters a current moving due to west at 3 knots, find the true speed to 1 decimal place and the direction of the boat to nearest degree. So before starting the solution of this problem, we need to know what is knot. Knot is nautical miles per hour, and 1 knot equals to 1.15 miles per hour. So it's the measurement in ship or in ocean. That's how they measure the distance, nautical miles. And bearing, this is the bearing. So let's draw the scenario here. Let's say this is the north side, this is east, south and west. So the boat is running in this bearing. That means the boat is running in this direction. It's in the still water. We define this as V subscript B. B stands for boat. The velocity of the current is moving this direction. We denote this as Vc, and this is also a vector, and Vv, this is also a vector. Now we can apply the law of vector addition, triangle law of vector addition. So the resultant vector will be represented by this line. Let's say this is the vector V. Vector VB, since its component is given as it's moving at 10 knots, so VB is 10 cosine. By the way, this angle is 25 degrees. So the total angle here is 115 degrees. So the vector V equals to cosine 115 degrees plus 10 sine 115 degrees. And the vector VC, the VC is moving directly from east to west. Therefore, it will not have any, y-axis movement. So it's parallel to x-axis. So it's moving only one direction, in the x direction. So it's in the negative direction. It should be 3i, since the current is passing at 3 knots. So our vector addition law, V equals to VB plus VC, which is equal to 10 cosine. I think I missed ij here, so I think I should put I here and j here. We can put I in front or at the end, it's not a big issue. So 10 cosine 115 I plus 10 sine 115j minus 3i. So we can group these I coefficients. We can group the I terms. 10 cosine 115 minus 3i plus 10 sine 115j. So the vector is approximately equal to negative 7.2i plus 9.1j. I have used calculator to calculate these values. So the true speed, we need to find true speed. That should be the magnitude of this vector v, which is equal to square root of negative 7.2 squared plus 9.1 squared, and that should be approximately equal to 11.6 knots. And the direction theta equals to tan inverse b over a, which equals to tan inverse b is 9.1 and a negative 7.2, and which should be approximately equal to negative 52 degrees. But we want positive angle, so we should write theta equals to 128 degrees. How did I get this value? I subtracted this calculated value from 180 degrees since it's in the second quadrant. So 180 degrees minus 52 degrees, this equals to 128 degrees. We need the direction angle to be positive.